I am Radhakrishna, mathematics teacher. Today we are going to start calculus of the 12th class with indefinite integration first lecture. Okay, let us discuss what is integration. If d by dx of g of x is equal to f of x, then g of x is called integral of f of x. We write it as integral f of x dx is equal to g of x. If d by dx of g of x is g dash x, if g dash x is equal to f of x, then we write integral, this is the symbol for integration, integral f of x dx is equal to g of x plus c. Why should we write plus c? Because derivative, if the derivative of g of x is f of x, derivative of g of x plus any arbitrary constant is also f of x. So, in every integration we have to write a constant c, which is called integration constant. And why should we use this symbol? This symbol is used because the meaning of integration is summation. It is just like sigma. This sigma is used for discrete summation. If you take sigma f of r, here r takes usually integral values. So, this is called discrete summation, r is equal to 1, r is equal to 2, r is equal to 3 and so on. And this integral is used for continuous summation. So, sum of the values of f of x. That is why we use this symbol which looks like S. See, this is S and this symbol looks like S. Okay. So, that is the meaning of integration, and in application you will come to know about what kind of summation it is. And we write dx because we should know with respect to which variable we are integrating f of x. Okay. And the function which is being integrated, this function is called integrand. And g of x is plus c is called integral. Okay. And since it is anti-process of differentiation, integral can also be called as antiderivative. So, integration is nothing but anti-differentiation. Okay. If you are finding the integral of f of x, then you should know f of x is the derivative of which function, that is called integral. Okay. And this integral or antiderivative is also known as primitive. Right. And the process of finding the integral from the integrand is called integration. Okay. Now, let us discuss some standard integrals which can be understood from the differentiation. Standard integrals. Integral sin x dx is minus cos x, because you know that derivative of cos x is minus sin x. D by dx of cos x is minus sin x, and derivative of minus cos x is plus sin x. So, integral of sin x is minus cos x. It is very easy to understand from the formula of differentiation. Next is integral cos x dx is equal to sin x plus c, because derivative of sin x is cos x. Integral secant square x dx is tan x plus c, okay, because derivative of tan x is secant square x, all of you know that. And similarly, derivative of cot x is minus cosecant square x. So, integral cosecant square x dx is minus cot x plus c, right. Next, integral secant x tan x is secant x plus c. You know that derivative of secant x is secant x tan x. So, integral of secant x tan x is secant x plus c. Integral cosecant x cot x is minus cosecant x, because derivative of cosecant x is minus cosecant x cot x. D by integral of x power n with respect to x is x power n plus 1 by n plus 1, because you know the formula in differentiation, d by dx of x power n is n x power n minus 1. If you want to use it as a formula in integration, integral of this will be this, but integral of n x power n minus 1 dx is equal to x power n plus c. It won't be convenient to use this formula, because every time you have to convert that function in the form of n x power n minus 1 and use this formula. So, this is not convenient. So, what we do is we modify. You take this n to LHS, then the derivative of x power n by n is x power n minus 1. Replacing n by n plus 1 on both sides, this becomes d by dx of x power n plus 1 by n plus 1 is equal to x power n x power n. So, integral x power n dx is x power n plus 1 by n plus 1, except for n not equal to minus 1. If n is equal to minus 1, RHS is not defined. If n is equal to minus 1, what will be the integral? It is x power minus 1, which is 1 by x. And you know that 1 by x is the derivative of log x, natural logarithm of x, okay. And the derivative of ln mod x is also 1 by x. So, when we use it as antiderivative, we write integral of 1 by x as ln mod x, because in 1 by x, x can be negative also, but ln x is not defined when x is negative. That is why we have to take mod x plus c, right. Next, integral 0 dx is c, because derivative of constant is 0. Integral 1 dx is x, because derivative of x is 1, okay. Actually, we can use this formula and get it by writing 1 as x power 0. We will get x power 0 plus 1 by 0 plus 1, which is x. Next, for some values of n, you should remember the formula directly instead of writing this and then simplifying. For some values of n, for example, n is minus 2. If n is minus 2, we get 1 by 1 plus x square, 1 by x square, which is integral x power minus 2. If you apply that formula x power n plus 1 by n plus 1, you will get x power minus 2 plus 1 x power minus 1 by minus 1, that is minus 1 by x. We should remember directly. Next, integral 1 by root x dx, by writing x 1 by root x as x power minus 1 by 2, we can use that formula, previous formula, and get 2 root x, but remember this directly. In differentiation also, all of you remember that derivative of root x is 1 by 2 root x directly. Derivative of 1 by x is minus 1 by x square. Similarly, in integration, we should remember the shortcut way. Integral 1 by root x dx is 2 root x plus c. Integral 1 by x power n dx. It is better to remember this formula also, because this formula is not given in many books. It will not be taught also. But if you can remember this, you can solve the questions easily without any calculation work. Okay. By writing this 1 by x power n as x power minus n, and then using the previous formula, we get minus 1 by n minus 1 x power n minus 1 plus c. Next, you know that derivative of a power x is d by dx of a power x is a power x into ln a, means log a to the base e. Ln a is a constant, so taking it into LHS, we get derivative of a power x by ln a is a power x. So, we get integral a power x dx is a power x by ln a, it is a formula. Similarly, you know that formula that derivative of e power x is e power x. So, integral of e power x is e power x. Next, hyperbolic functions. Derivative of cos hx is sin hx. So, the derivative integral of sin hx is cos hx. Similarly, derivative of sin hx is cos hx, and integral of cos hx is sin hx. You must be aware sin hx is a hyperbolic function which is defined as e power x minus e power minus x by 2, and cos hx is e power x plus e power minus x by 2, and remaining are as usual. Tan hx is sin hx by cos hx, and 1 by tan hx is cot hx. And 1 by sin hx is cosecant hx. And 1 by cos hx is secant hx. So, there are 6 hyperbolic functions, just like 6 trigonometric functions: sin theta, cos theta, tan theta, cot theta, secant theta, cosecant theta are there in trigonometry. Similarly, sin hx, cos hx, and the remaining are defined just like trigonometric functions, but initial definition is, in trigonometric function, sin theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse in a right angle triangle, but in hyperbolic functions they are defined like this. Okay. So, actually you may not require it for IIT, okay, but it is better to learn hyperbolic functions also in differentiation and integration. Now, remaining formulae will be similar to the formulae of trigonometry. Integral secant h square x is tan hx. Integral of secant square theta is tan theta, na? Same. Integral cosecant square theta is minus cot theta. Similarly, integral cosecant h square x dx is minus cot hx. This formula is little different. In trigonometry, integral secant x tan x is equal to plus secant x. Here, integral secant hx tan hx is minus secant hx. Integral cosecant hx cot hx is minus cosecant hx, same as trigonometry, only this is different. remaining, and here also integral of sin x is minus cos x. So, this is different from trigonometry formulae. Next, we have already discussed integral 1 by x dx is ln mod x. Next, we know that derivative of sin inverse x is 1 by root 1 minus x square. So, integral of 1 by root 1 minus x square is sin inverse x plus c. Derivative of cos inverse x is minus 1 by root over 1 minus x square. So, shifting that minus sign, we get integral of 1 by root 1 minus x square is minus cos inverse x. So, we can write sin inverse x plus c or minus cos inverse x plus c. Integral 1 by 1 plus x square is tan inverse x, because derivative of tan inverse x is 1 by 1 plus x square. And we can also write the integral as minus cot inverse x plus c, because derivative of cot inverse x is minus 1 by 1 plus x square. If you write tan inverse x as pi by 2 minus cot inverse x, then this pi by 2 plus c becomes this constant. So, this c is different, this c is different. Okay. Next, from the differentiation formula, derivative of secant inverse x is 1 by mod x root x square minus 1. So, integral is the reverse formula. You can also write this integral as minus cosecant inverse x plus c. Integral 1 by root 1 plus x square is sin h inverse x, sin h inverse x plus c. But every hyperbolic function can be expressed as a logarithmic function. Sin h inverse x is ln of x plus root 1 plus x square plus c. So, usually in IIT we write this integral as a logarithmic function. Next, integral 1 by root x square minus 1 dx is cos h inverse x plus c, or cos h inverse x is ln of x plus root x square minus 1 plus c. Okay. And all of you must be thorough in all these basic integrals or standard integrals, then only we can proceed further. Now, some more results. Integral f dash x by f of x dx is ln mod f x. You look at the result from RHS. What is the derivative of ln f x? 1 by f of x into f dash x. All of you know this method. Derivative of ln mod x is 1 by f of x into derivative of f of x is f dash x. So, it is f dash x by f x. Then integral of f dash x by f x will be ln mod f x. We should remember the formula directly. Next, integral f dash x by root f x will be 2 root f x. If you check from RHS, derivative of 2 root f x will be f dash x by root f x. So, integral is integral of f dash x by root f x is 2 root f x. You should by heart the formula. Next, in differentiation, when you are differentiating f of ax plus b, what will you do? Assuming that ax plus b as x, you will differentiate, you will get f dash ax plus b. Then you will multiply by the derivative of ax plus b. What is the derivative of ax plus b? It is a. In integration, we divide by a. Integral f dash ax plus b is assuming that this is x. Integral f dash x is f of x. Then divide by inner derivative, derivative of ax plus b, that is a. But remember, by assuming something as x and integrating, then dividing by the inner derivative, that is valid only when the inner derivative is a constant. For example, you want integral of f dash ax square plus b is there. Here assuming ax square plus b as x, integral of f dash x is f of x, f of ax square plus b, then divide by derivative, inner derivative. What is the derivative of ax square plus b? 2ax. This is wrong, you should not do. We can do this only when the inner derivative is a constant. Okay. Next, integral of tan x is ln mod secant x plus c or minus ln mod cos x. In the previous results, we have discussed the integrals of sin x and cos x only. We did not discuss the integrals of tan x, cot x, secant x, cosecant x. Now we are going to derive them using this formula. How the derivative of integral of tan x is log mod secant x, integral tan x dx. In order to use this formula, we multiply and divide by secant x. Then it becomes secant x tan x upon secant x. Now derivative of secant x is secant x tan x. So it is in the form of f dash x by f x. So its integral is ln mod denominator, ln mod secant x. And secant x is 1 by cos x or cos x whole power minus 1. So it becomes minus ln mod cos x also. Next, integral cot x dx is ln mod sin x. You can write cot x as cos x by sin x. Now you observe that derivative of denominator is numerator. If denominator is f of x, numerator is f dash x. Using the previous formula, integral f dash x by f x is log mod f x, we get this is equal to ln mod sin x. Similarly, integral secant x dx is ln mod secant x plus tan x plus c, and we can also write it as ln of mod tan pi by 4 plus x by 2. Let us see how. This time we multiply and divide by secant x plus tan x. Secant x is multiplied by secant x plus tan x and divided by the same. Now numerator is secant square x, this into this, plus secant x into tan x by secant x plus tan x, right. Now observe it, derivative of secant x plus tan x is secant x plus tan x plus secant square x. It is f dash x by f x. What is the integral? Ln mod f x. Now this secant x plus tan x can be expressed as, this is 1 by cos x plus sin x by cos x. We get 1 plus sin x by cos x. If you write it as 1 minus cos of pi by 2 plus x by sin pi by 2 plus x. Cos pi by 2 plus x is minus sin x. Sin pi by 2 plus x is cos x. Now 1 minus cos theta can be written as 2 sin square theta by 2. Theta by 2 is pi by 4 plus x by 2. upon, we can write sin theta as 2 sin theta by 2 cos theta by 2. 2 sin pi by 4 plus x by 2 into cos pi by 4 plus x by 2. Then 2 cancels, sin theta cancels. What is the remaining? Sin by cos, tan pi by 4 plus x by 2. It is the resultant trigonometry. Secant x plus tan x is tan pi by 4 plus x by 2. Next, in the same way, we can prove that integral cosecant x dx is ln mod cosecant x minus cot x. This time you should multiply and divide by cosecant x minus cot x. Then it becomes f dash x by fx, you will get log mod fx. And by trigonometry, this can be proved as tan x by 2 by writing 1 by sin x minus cos x by sin x, 1 minus cos x by sin x, and simplifying by trigonometry we get tan x by 2. Okay. Now some more properties. In integration, if you have k into f of x as integrand, that k is a constant independent of x, that can be taken out. We get k f of x dx, just like differentiation. Another is, if when you are integrating sum or difference of two functions, integral of f of x plus g of x or f of x minus g of x, you can separate the integrals and write it as integral f of x dx plus or minus integral g of x dx. This is another formula. But if it is a product, when you are integrating a product f of x into g of x, we should not integrate separately and multiply. This is not equal to integral f of x into integral g of x. Similarly, when you have integral of f of x by g of x, we should not write it as integral f of x by integral g of x. There are some methods to calculate this kind of integrands, f of x into g of x or f of x by g of x, we are going to learn later. Now, there are 4 basic methods of integration. They are, one is integration by decomposition, another is integration by substitution, next is integration by parts, last is integration by successive reduction. These 4 are the main methods of integration. Today we are going to discuss about integration by decomposition. What is this method? When you want to integrate some function with respect to x, then if you cannot tell the integral directly, if it is not a standard result, then first we try to decompose the function into sum or difference. Decomposition means splitting the function into sum of 2 or more functions or difference of 2 or more functions. That is the meaning of decomposition. Okay. This is the first basic method. First we should try decomposition method. Now we can understand this more clearly through problems. One simple problem, integral 1 plus x square by x into 1 plus x square dx. Directly it is not a standard result, so what to do? We try to decompose it. Integral, let us write numerator as 1 plus x square plus x by x into 1 plus x square, denominator as it is. just we have rearranged the numerator. After rearrangement, if you separate the denominator, we get integral 1 plus x square by x into 1 plus x square. We can separate the integrals now. So, I am writing separate integral for this and this by this plus x by x into 1 plus x square dx. Now, you see what happens here, 1 plus x square cancels, here x cancels. What is the remaining here? Integrand is 1 by x, integral 1 by x dx, which is a formula, plus integral 1 by 1 plus x square dx. This is also a formula. So, now write the formula. Integral 1 by x is ln mod x plus integral 1 by 1 plus x square is tan inverse x. Plus c. This is our answer. And you do not need to write separate constants here and for this integral and this integral. After integrating, finally you write just plus c in any question. Even if there are 2 or more integrals, only one constant c is enough. Okay. Now, proceeding to second question. Integral secant square x cosecant square x. We know the integral of secant square x, we know the integral of cosecant square x separately, but as we discussed, we cannot directly substitute the integrals of secant square x and cosecant square x when it is a product. It can be done only for sum or difference. So, we have to decompose this using the formula of trigonometry. First, we will write it as secant square x is 1 by, second question, secant square x is 1 by cos square x, cosecant square x is 1 by sin square x. So, we write it as 1 by cos square x into sin square x. This is very simple formula in trigonometry. Now, in order to decompose, we use the relation between cos square x and sin square x. What is the relation? Sin square x plus cos square x is 1. In numerator, 1 is there. So, we write it as sin square x plus cos square x upon cos square x sin square x. Now, you will easily understand what to do. By separating the denominator, sin square x by cos square x into sin square x, sin square x cancels, we get 1 by cos square x. I will write separate integrals, plus cos square x by cos square x into sin square x is 1 by sin square x, cos square x cancels. So, it is integral 1 by sin square x. What is 1 by cos square x? It is secant square x. What is the integral of secant square x? Formula, it is tan x. And this is 1 by sin square x, which is cosecant square x. What is the integral of cosecant square x? Minus cot x. We can substitute because it is plus. So, tan x minus cot x, we write only one constant plus c. So, this is the integral of 1 by cos square x into sin square x or secant square x into cosecant square x. We can also do like this. We can write secant square x as 1 plus tan square x and cosecant square x as 1 plus cot square x multiply the two brackets, you are going to get 1 into 1 1 plus tan square x into 1 tan square x, 1 into cot square x, and finally tan square x into cot square x is 1. You know that tan x and cot x are reciprocals to each other. So, tan square x into cot square x is 1. So, plus 1. Then again 1 plus tan square x is secant square x plus cot square x plus 1 is cosecant square x. So, it becomes secant square x plus cosecant square x. For addition, we can write the separate integrals tan x for first term and minus cot x for second term, right. Next question, integral 2x plus 3 whole cube by x. How to decompose it? Simply you expand the whole cube. What is a plus b whole cube? A cube plus 3a square b plus 3ab square plus b cube. So, it is a cube means 2x whole cube, 8x cube plus 3 a square b means 3 into 4x square, 3 into 4x square into 3, that will be 36x square. Next 3 into 2x into 3 square, that will be 54x. Next is 3 cube, 27 divided by x. Now, simply separate x to each term. You will get integral 8x square plus 36x plus 54 plus 27 by x dx. Now, integrate each term. 8 is constant, 8 into integral of x square is x cube by 3 using our formula x power 2 plus 1 by 2 plus 1. So, 8x cube by 3 plus 36x. Integral of x is x power 1 plus 1 by 1 plus 1, that is x square by 2. So, this 36 becomes 18 x square. 54 is a constant. So, take it as 54 into 1, we know that integral of 1 is x. So, integral of 54 is 54x plus 27 into integral 1 by x is ln mod x plus c. Okay. Next question, integral 1 by 1 plus sin x. Integral 1 by 1 plus sin x dx. Here we can solve it in two methods. Method 1, method 1. In this method, we multiply and divide by the conjugate of 1 plus sin x. What is the conjugate of 1 plus sin x? It is 1 minus sin x. Just by changing the sign in between, we call it as conjugate generally. So, multiplying and dividing by 1 minus sin x, we get 1 minus sin x by, what is 1 plus sin x into 1 minus sin x? It is 1 minus sin square x. We know that 1 minus sin square x is cos square x. So, it is 1 minus sin x by cos square x. Now, separate the denominator, it is decomposed. It is 1 by cos square x minus sin x by cos square x. Dx. What is 1 by cos square x? Secant square x. Minus, how can you write sin x by cos square x? Sin x by cos x is tan x and 1 by cos x is secant x. So, it is secant x tan x. And both are standard integrals. What is the integral of secant square x? Tan x. Integral of secant x tan x is secant x. So, it is tan x minus secant x. We can write only one constant c. Okay. This is first method. Now, second method. Method 2. In this method, I will write sin x as minus cos pi by 2 plus x. 1 by 1 minus cos pi by 2 plus x dx. Particularly in integration, there will be 2 or more methods for many problems. Unless you learn all the methods, you will not be able to solve some questions. Some more than correct answer type questions cannot be solved without knowing all the methods, because he might solve the questions, he might integrate it in different ways, and all the 4 options may be correct. Okay. So, that is why we need to learn as many methods as possible. After writing this, we can write 1 minus cos theta as 2 sin square theta by 2. Okay. You can also write it as 1 plus cos pi by 2 minus x. Okay. Now, 1 minus cos theta is 2 sin square theta by 2, 2 sin square theta by 2 is pi by 4 plus x by 2. Now, 1 by sin square is cosecant square. So, you can write it as half into integral 1 by sin square is cosecant square pi by 4 plus x by 2. Now, assuming that this is some x, because it is in the form of ax plus b, inner derivative is constant 1 by 2. So, I can assume that this is x, then integral cosecant square x is minus cot x. So, its integral is minus, write half as it is, minus cot x. It is cot of pi by 4 plus x by 2. Then what should we do? We should divide by inner derivative. What is the inner derivative? Derivative of this is 1 by 2. So, divided by 1 by 2 plus c. This 1 by 2 cancels. So, answer is minus cot pi by 4 plus x by 2. Okay. And we can also solve this second question in a second method. Second question, another method. We have written secant square x as 1 by cos square x, cosecant square x as 1 by sin square x. We get 1 by cos square x sin square x. Now, instead of decomposing, we can combine them into a single function. How? You know the formula 2 sin x cos x is sin 2x. So, I will multiply by 2 square here. 2 square is a constant, so I can multiply by 2 square outside. The value remains same. Now, 2 square is 4 integral 2 cos x sin x is sin 2x. So, it becomes 1 by sin square 2x. 1 by sin square theta is cosecant square theta. It is integral cosecant square 2x. What is integral cosecant square x minus cot x? But it is 2x, but no problem. We can assume 2x as x and integrate, then we divide by inner derivative. Assuming that 2x is x, its integral is minus cot 2x. 4 is there, so it becomes minus 4 cot 2x. Then what should we do? Divide by derivative of 2x. It is divided by 2 plus c. Now 2 cancels, we get minus 2 cot 2x plus c. Okay. Next question, integral 1 by 1 plus sin x is, that is over. Next is integral sin cube x. Before this, I will solve integral as fifth question. I am solving integral cos square x dx. What to do? We can write cos square x as 1 plus cos 2x by 2. Take half outside, half into integral of 1 is x and integral of cos 2x, assuming that 2x is x, integral of cos x is sin x, no? So, integral of cos 2x is sin 2x, then we have to divide by inner derivative, derivative of 2x is 2. So, divided by 2 plus c. Now, if it is cube, integral sin cube x dx, what will you do? You know the formula of sin 3x. Sin 3x is 3 sin x minus 4 sin cube x. From this, you can find sin cube x in terms of multiple angles. 4 sin cube x is equal to 3 sin x minus sin 3x then sin cube x is equal to 1 by 4 into 3 sin x minus sin 3x. Now write sin cube x using that formula. We can write 1 by 4 outside the integral, and remaining is 3 sin x minus sin 3x. Now you know how to integrate it. 3 is constant, so write it as it is. What is the integral of sin x minus cos x? Integral of sin 3x is minus cos 3x by 3. Inner derivative of 3x is 3. Minus of minus becomes plus cos 3x by 3 plus c. So this is the method of integrating sin cube x. Similarly, if it is cos cube x, use cos 3x formula. Next, in the same way, if it is sin power 4x, how to integrate? First we write sin power 4x as sin square x whole square, and sin square x can be written as 1 minus cos 2x by 2 whole square. Now write denominator is 2 square 4, take it out as 1 by 4, 1 minus cos 2x whole square is 1 minus 2 cos 2x plus cos square 2x dx. Now 1 by 4 into 1 minus 2 cos 2x, these two can be directly integrated, but here problem is third term. When square is there, you do not have a formula. So we should write cos square 2x as 1 plus cos 4x by 2. Cos square theta is 1 plus cos 2 theta by 2. Then simplifying, 1 by 4 integral 1 plus 1 by 2, 3 by 2 minus 2 cos 2x plus cos 4x by 2. Now you can integrate it. Integral of 3 by 2 is 3x by 2. Integral of cos 2x is sin 2x by 2. Integral of cos 4x is sin 4x by 4. Like that you substitute the formulae. You can finish it. I will move to next question. Integral sin 2x into cos 3x dx. When there is a product like this, we know the separate integrals, but we cannot substitute separately integral of sin 2x and integral of cos 2x. We have to decompose this product into a sum. In trigonometry, you have studied about transformations, expressing a product of trigonometric functions as sum or difference. We have to use transformations and decompose it. For applying transformations, you first multiply by 2 and divide by 2. Then take larger angle as A, smaller angle as B. It is 2 cos A sin B. What is the formula? 2 cos A sin B is equal to, in trigonometry transformations, sin A plus B minus sin a minus b. It is a formula. So, by using that formula, half integral sin of a plus b means sin of 3x plus 2x, sin 5x, minus sin of a minus b. A is larger angle 3x, 3x minus 2x, that is x. Now it is decomposed into a difference. Now we know the integral separately. Half into integral of sin 5x is minus cos 5x by 5. Integral of sin x is minus cos x. So, minus of minus is plus cos x plus c. Now, next question. This time it is a product of three functions, cos x into cos 2x into cos 3x. We have to decompose this product into a sum or difference, but we can use transformations for two terms at a time. All are cosines, so take the formula 2 cos A cos B is equal to cos A plus B plus cos A minus B. Using this formula, taking two at a time, we can take, usually we combine odd terms and even terms separately. So, I am combining this and this. In order to apply that formula, we need 2. So, multiply by 2 and divide by 2. Outside 1 by 2, inside write cos 2x separately, and remaining is 2 cos 3x cos x. Where you can apply this formula, half into cos 2x into 2 cos A cos B cos A plus B plus cos A minus B. Cos A plus B is 3x plus x 4x plus cos A minus B 2x. Again, after multiplying by cos 2x, this becomes a product. We have to apply that formula. So, multiply by another 2 and divide by 2. You will get 1 by 4 into integral multiplying by 2 cos 4x cos 2x. First write the larger angle, then smaller angle, plus second term is this into this cos square 2x into 2 cos square 2x. Now, applying that formula, 1 by 4 integral 2 cos A cos B cos A plus B plus cos A minus B. Cos A plus B is cos of 6x plus cos of A minus B, 4x minus 2x is 2x, plus this is 2 cos square theta. the formula in trigonometry is 2 cos square theta can be written as 1 plus cos 2 theta or cos 2 theta plus 1. Cos 2 theta means 4x plus 1. Now, all terms are integrable using standard integrals. It is 1 by 4 into integral of cos 6x is sin 6x by 6. Integral of cos 2x is sin 2x by 2. Next is sin 4x by 4. Last is 1, integral of 1 is x plus c. Okay. Next question, integral tan x into tan 2x into tan 3x dx. It is a product of 3 functions, but it is in tan. There is no such formula in tan. So, what to do? First, we observe that x plus 2x is equal to 3x. X plus 2x is equal to 3x. Applying tan on both sides, tan of x plus 2x is equal to tan 3x. You know the formula of tan of a plus b. It is tan a plus tan b, tan x plus tan 2x by 1 minus tan x into tan 2x. Is equal to tan 3x. Now, cross multiplying, tan x plus tan 2x is equal to 1 into tan 3x minus this into this, tan x into tan 2x into tan 3x. Now, we got the same product in this equation. Using this, we can express that product as a sum or difference. It is tan x into, taking it this side, tan x into tan 2x into tan 3x is equal to tan 3x minus tan 2x minus tan x. Right. Now, integrate on both sides. Integral tan x tan 2x tan 3x dx is equal to, directly I will write, what is the integral of tan 3x? We discussed the integral of tan x. Integral of tan x is log mod secant x. Assuming that 3x is x, later we can divide by 3, inner derivative 3. Integral of tan 3x is ln mod secant 3x divided by 3. Integral of tan 2x with minus sign, ln mod secant 2x by 2, same as this. Next is minus integral of tan x is ln mod secant x plus c. It is finished. Next question. Integral 1 by sin x plus alpha into sin x plus beta. Or the same can be asked as integral cosecant x plus alpha into cosecant x plus beta. We have to decompose it. We observe that difference between the angles x plus alpha and x plus beta is constant, alpha minus beta, this minus this or this minus this. So, we write numerator as sin of x plus alpha minus of x plus beta. What is this? Sin alpha minus beta, which is constant independent of x. That means we have multiplied the integrand by sin of alpha minus beta. So, we have to divide outside by sin alpha minus beta by sin x plus alpha into sin x plus beta. Now, using sin a minus b formula, you expand it. 1 by sin alpha minus beta into, it is in the form of sin a minus b by sin a sin b. Okay. Sin of a minus b is sin a cos b minus cos a sin b. By sin x plus alpha into sin x plus beta. Right. Now, you see what happens if you separate the denominator. 1 by sin alpha minus beta into integral this by this product by this product, sin x plus alpha cancels, cos x plus beta by sin x plus beta is cot x plus beta. Minus this product by this product, this time sin x plus beta cancels, cos x plus alpha by sin x plus alpha is cot x plus alpha. Okay. Alpha and beta are constants. You know the integral of cot x. Integral of cot x is ln mod sin x. So, this integral is 1 by sin alpha minus beta into ln mod sin x plus beta minus ln mod sin x plus alpha. Plus c. If you want, you can simplify it further. Log a minus log b is log a by b, no? So, it is 1 by sin alpha minus beta ln mod sin x plus beta by sin x plus alpha. Plus c, right. if your denominator is cos x plus alpha into cos x plus beta, if both are cosines, then also you should multiply and divide by sin alpha minus beta only. Okay. If one is sin, another is cos, then you should multiply by cos alpha minus beta. Write numerator as cos of x plus alpha minus x plus beta, divide by cos alpha minus beta, and you try. Next question. This time cos x plus alpha by cos x plus beta. How to decompose it? In the earlier question it was a product, this time it is a ratio. We write x plus alpha in terms of x plus beta, and then denominator can be separated and calculated. You can calculate the integral. How to write x plus alpha in terms of x plus beta? You can write as x plus beta plus alpha minus beta. It is x plus alpha only now, by cos of x plus beta. Now, taking this as A, this as B, apply cos A plus B formula. It becomes cos A cos B, cos x plus beta into cos alpha minus beta minus sin A sin B, sin x plus beta into sin alpha minus beta. By cos x plus beta. Right. Separate the denominator. X plus cos x plus beta cancels. After cancellation you will get cos of alpha minus beta minus, in the second, sin x plus beta by cos x plus beta is tan x plus beta. Into sin alpha minus beta. Dx. Here cos of alpha minus beta is just constant, just like k. What is the integral of k? It is kx. So, over here you will get x into cos alpha minus beta. Over here sin alpha minus beta is constant. So, just like k, and integral of tan x plus beta is ln mod secant x plus beta. So, it will be minus of sin alpha minus beta into integral of tan x plus beta ln mod secant x plus beta plus c. Only one c is enough. Next question. Integral tan x plus alpha into tan x plus beta. How to decompose? First observe that the difference between x plus alpha and x plus beta is constant, alpha minus beta. So, I will take x plus alpha minus of x plus beta is equal to alpha minus beta. Applying tan on both sides, tan of a minus b formula, tan a minus tan b, that is tan x plus alpha minus tan x plus beta by 1 plus tan a tan b, 1 plus tan x minus alpha into tan x minus beta is equal to, applying tan on RHS, tan alpha minus beta. Now cross multiplying, we get 1 plus tan x plus alpha into it is x plus, cross multiplying 1 plus tan x plus alpha into tan x plus beta is equal to tan x plus alpha minus tan x plus beta upon tan of alpha minus beta. Now integral tan x plus alpha into tan x plus beta will be, taking 1 to right side, tan x plus alpha minus tan x plus beta by tan alpha minus beta minus 1, right. Tan alpha minus beta is constant. So what will be the integral? Write 1 by tan alpha minus beta into integral of tan x plus alpha is log mod secant x plus alpha, and integral of this is log mod secant x plus beta. Log a minus log b is log a by b. So I am writing the direct step, log mod secant x plus alpha by secant x plus beta, and the integral of 1 is x minus x plus c. Okay. Now last question, integral 1 by root 2x plus 3 plus root 2x minus 1. For this kind of terms, we rationalize the denominator, multiplying and dividing by this minus this, you will get root 2x plus 3 minus root 2x minus 1. What will you get in the denominator? This plus this into this minus this will be a square minus b square. This square 2x plus 3 minus 2x minus 1. And what will get? Denominator will be 4. 2x cancels. 1 by 4 integral root over 2x plus 3 can be written as 2x plus 3 power 1 by 2 minus 2x minus 1 power 1 by 2. Now assuming that this is some x, integral of x power 1 by 2 is x power 1 by 2 plus 1 by 1 by 2 plus 1, you will get 2 by 3 into 2x plus 3 power 3 by 2. Then we have to divide by inner derivative 2 by 2 minus same, this is 2 by 3 into 2x minus 1 power 3 by 2 by inner derivative of 2x minus 1 by 2. 2 cancels, then simplify the remaining. Okay. So, with this we are going to close the session for today, and we are going to continue this chapter tomorrow. Okay. So, have a good day. Thanks for watching.